So hi again, and in this video I'm going to focus on the overall design of the system that I developed that allows to track the mobile application performance. So imagine you are the mobile application developer that has the successful mobile application. So you have users like around all around the world that are launching your application, and you want to basically know, like you might want to know many things about how the application is performing. But so I decided to focus on the things that that were most critical for me, and that's going to be unique users per period and crashes that application is reporting. So I'm going to focus on these two things. So when the application starts and when application crashes. So I'm going to send, so our mobile application is going to send those events to the service, the backend service that's I'm going to call event service. And well, because we want that service to be highly available and scalable and fault tolerant and so on, so we're going to have the actual multiple instances of that service running, and to be able to spread the load across the services, we're going to use the load balancer in front of it. So the mobile application, when the user starts a mobile application and if it crashes, we're going to have an event sent to our load balancer. A load balancer is going to distribute that event to one of the event services running. So that event service is going to have pretty simple API. We're going to just have this post event method available, and we're going to accept the event as an input parameter. So we're going to be communicating with this application using JSON, so just sending the JSON format messages. And what's going to be in that event, let's focus on that. So basically event, so that's a JSON document. It can have, well, it can be, first of all, it can be of multiple types. So we're going to support start event, or launch event, and crash event. So let's say we have a crash event, so for the crash you're going to use C as a type. We're going to have the application code. So that's application code. So this application code, this is something that the mobile developer has to get from our service when she registers for our service. And it's going to be unique for that application. So this application code has to be put in the code of the mobile application. So every time it submits the events, it also sends that unique application code that is unique for that application. So that's gonna be some unique code. We're also going to have user ID, and that's going to be unique. Some kind of unique identifier that is generated inside the mobile application and unique for per every user. So we're going to have some kind of code. So that's going to be used to identify the unique users. So we're also going to have the date and the time that event was sent. That's the date and the time that's coming from the client. So for example, we are in 2019 February, and so we're going to have that as a date. And also optionally, in case, it's going to be optional fields, but we're going to use them for crashes. So for crashes, because it comes from the exception, so we're going to have this message that was on the exception is going to be something like null ref exception and so on. And we're going to have the details. The details, that's going to be a field that contains the full stack trace of that exception. So it's going to be base 64 encoded string that we're going to use. So this is basically the format of the event we're going to send. The service that we're going to use, it's not going to do much processing. We want it to be as simple as possible, so just ingest the event and returns as quick as possible, so that we can also have the so we could serve multiple users on multiple applications with minimal effort. So only thing we're going to do here on the server, we're going to enrich this event with the extra field that is datetime on the server, because basically the datetime that's coming from the mobile device, it might be not really reliable. So we're going to have more reliable date and time on this this backend service, and we're going to use that one to calculate all the statistics. So as I said, this service has to be very, very like lightweight and do the minimal operations. So what is it going to do? It is actually going to just do one thing. It's going to put this event in a message queue for the further processing for actual calculation of the statistics. So there are multiple choices for the message queue. So I've chosen for this one to use Kafka. So the Kafka, what is Kafka? But Kafka basically allows you to reliably store a massive amount of events that are immutable. So we're going to have these events that are actually going to be immutable. So we're just going to generate them every time that application is started or crashed, and we're not going to go back and modify any of those data. So that's a good feat. Kafka also allows you, so it allows you to store that reliably, so it persists on a disk, but it also, because it actually will run in a cluster of machines, so it provides you the fault tolerance, scalability, and high availability. So what we're going to do, we're going to actually submit this message to Kafka immediately without almost no processing, and we're going to have a user replication factor of 2, so that this event is actually stored on 2 instances of running Kafka. And so what we're going to do for the message, we're going to use, so as a key of that message, we're going to use application code, and as a value, we're going to use the event itself. So the essence of it, so the application code, so we use the key. The key is used to partition the events across machines. So in essence, what we have here is that all the events from the same application are going to end up in the same partition in order that they arrived. So that might be or might not be a correct design depending on the load. So I think this part has to be fine-tuned later, because in essence, if you have so many events for the one application that they don't fit on the one machine anymore, so that's going to be the problem. But for me, I didn't have that many events. I don't have that many users, so I never run into that problem. So for me, that's actually worked. So, but that's something like you could start but well, might require more careful planning for actual amount of events you're going to track. So what's going to happen next? So we're going to use this Kafka for its reliable and scalable storage of our events, immutable events, but we're going to also use it as event queue, and we're going to have our stats service here that is going to go through these events that recorded in Kafka and calculate the statistics. So these stats events, it's also for the scalability, we're going to have multiple of those services, and they're going to all look for the events, for the new events in Kafka. And as events arrive in Kafka, they're going to calculate statistics and put them in a different database. So I'm going to use, and I used here the MongoDB as my database. MongoDB. I used it as a database to store aggregates calculated based on those events. So that's a couple of things about MongoDB. This is a NoSQL solution. It has a good scalability and fault tolerance capabilities as well. And one of the main factors what helped me to decide MongoDB is that it's very easy to use the MongoDB from JavaScript, and since we're going to build this whole website that allows you to show the statistics in Node.js and JavaScript, so that was a very good candidate for me. It was very easy to access that MongoDB. So in MongoDB, we're going to, like as anything else, we're going to run it actually in a cluster. So I'm going to have actually 2 instances of MongoDB, and we're going to configure it in a way that we have one master node and we have replicas. So our statistics, when it's updated, is going to be written to the master node, and it's going to be replicated on replicas, and we're going to be able to use both of them to actually show the statistics to the user. So let's work a bit on that part before we go into the more details on what we store actually in that MongoDB and how we calculate that statistics. So our user, like our developer, he's going to access our application through the website, and that website, well, it's going to be called kaboom-report.com, and I've built it as basically as a single page React application, and it's going to get all the information so that to get the statistics, it's going to connect to the backend service that I'm calling web service. And again, as with anything else, we're going to have multiple instances of that web service. To be able to leverage multiple instances of that web service, we're going to have a load balancer in front of it. And so our mobile user is going to run requests against the load balancer, and the load balancer is going to distribute the traffic across multiple web services. So we're going to use, again, the JSON as a format to exchange the data with this web service, and we're going to use this JSON that comes here to render all our statistics and charts. So, well, what is going to be that API of that web service? So let's try to focus a bit on that. So first of all, we're going to have sign in endpoint. So that sign-in endpoint is going to, because we don't want just anyone on the web to access the statistics for a given application, so we're going to use Google sign-in. So for that, we're going to rely on a Google identity provider. And basically how it works, we're going to, from our application, we're going to be redirected to that Google identity provider, and we're going to submit username and password to the Google identity provider. In exchange to that, Google identity provider is going to give us back the token. Well, it's actually technically it's called ID token, but we're going just for simplicity, we're going to call it token. So in essence, what that token is, that token contains encrypted information about the user ID, the Google user ID of our mobile application developer, and they're going to have some special fields. So it's going to say that the token is issued for our website, kaboom-report.com. It's going to have the expiration date. So what we're going to do with that token, we're going to pass it in a sign-in method. So sign-in is going to just accept the token, and the sign-in is going to use the Google client library to validate the token. So it's going to check if the token is actually issued for our website, that it's not expired. And what we're going to do, we're going to put that token in a session. So for the next calls, we don't need to submit a token anymore. So for this one, we're going to use the session that is basically client-side cookie-based session. So for the simplicity, so we don't need any external storage for the session. So we're going to pass it just, so we're going to put the token actual, well, this token that we get in a session, and we're going to return this session in a cookie from the sign in. Well, once we're done with the sign in. So the sign in, we're going to have also sign out call, and that's basically just going to kill the session that our user has with that token. So that's a couple of functionality, a couple of API calls that allows to authenticate, and we're going to verify every time that we get, like we get a call to our backend, so that we're going to validate the token that is stored in that session, that it hasn't expired, and if it did, so we're going to force the user to relog in. That's kind of the basic flow. So what that sign in is going to do as well is going to actually give us the information about the application that we're going to use. So we're going to receive, with the session, we're going to receive actual application code that we're going to use for the all the rest of the calls to identify what application we're interested in. So what we're going to be allowed to do, so first of all, we're going to have API that's going to give us crashes. So for the crashes, we're going to submit that our application code, and yeah, that's going to be it. And we're going to get back crashes. So it's going to be an array of crashes. So a couple of notes about this API call. So even though we submit just application code, remember we have this token in the session submitted through the cookie. So we're going to have user ID there, the user ID of this user. So we're going to actually validate that application code that we submit, it belongs to that user ID, so we don't return occasionally the data for the wrong user. So for those crashes, we're going to return a couple of things. So this is so we just, at this point, when we get crashes, we just want to build the list of the crashes. So we're going to return. Basically, we're just going to return the for every crash. For every crash, we're going to return ID, message, and a counter. So we don't return all the details because I don't want this call to return too much. We're going to just have this front page. The list of the crashes built on the front page. We could also consider paging here, but because it's just a first version and I didn't have that many crashes, I decided to kind of cut the corner here and just return all the crashes. If the number becomes too much, we might want to introduce the paging here. So every crash, if you click on the details of the crash, then we're going to return the actual stack trace. So we're going to have the extra call that is called get crash, let's call it crash details. So we're going to have the application code and the crash ID submitted there. And for that crash, we're going to actually return, so we're going to return detailed crash info that's going to contain our details about that crash. So that's going to be useful to be able to build the list of crashes. So we also want to show the charts, the showing unique users and number of crashes per period. So we're going to have a couple of APIs. So first of all, we're going to have get unique users stats, let's call it like that, and it's going to be again app code. And we're going to accept the period that's and a date and actually what that period is. So for example, if we're going to return the crashes, for example, for this month, so we're going to submit the month as a period, as a value for the period, and we're going to submit the date that identifies that month. So for example, that's going to be month for the actual type of the period, and the date is going to be the 2019-02. That's going to identify our month. So that's kind of the idea. But so we're going to pass that as a period parameter and the date time. So what it's going to return is going to return us the stats, and yeah, the stats is going to be basically let me align this. So what the stats going to contain, if that was a month, it's going to contain for every day in that month what was the counter of the unique user. So the stats is basically the day and count in case of the months. If you're asking for the statistics for the year, that's going to be month and account. So similar to that, we're going to have stats for get crush stats, and we're going to submit again application code period and actually what that period is. So similar. So that will allow us to build the charts, and so our web service is going to get all that statistics from MongoDB. It can connect either to master or the replica, so it doesn't matter. But if one of the instances of MongoDB is offline, we're just still going to use, well, if the master is offline, we're going to be able to use replicas to get that information back to the mobile application developers. So at this point, we kind of covered these parts, the APIs and the services. So let's look just more in details on what we're going to store in that MongoDB actually. So we're going to have a couple of collections there. So first of all, we're going to have users. So for the users, we're going to have user ID. So that's user ID. It's a Google user ID that we're getting from the token. And for that, we're going to have app code. So the first time user logs in, it's going to be given the application code that's going to be randomly generated. It's going to be big GUID. So that's application code. Once we get that, we will be able to use that to access all the rest of the information. So one of the things I didn't want to, well, since that application code I actually generated and stored here as a big string with the unique identifier, well, I didn't want to use that for everything else. So I actually have an extra collection here that is just going to contain link of the application code. So it's going to link the application code to the Mongo generated application ID, and that application ID is going to be just 12 bytes number that's generated by Mongo. So we're going to use that everywhere else. So a couple of other collections we're going to have. So we're going to have user launches by month. What's that going to contain? So that's going to be our application ID, so we can link this launch to our application. We're going to have user ID. This user ID is the user ID actually that we get from the mobile application. So that's unique identifier that is generated uniquely for every user of the mobile application. And we're going to have so the date time. So this is by month, and date time is going to again identify that actual month that we're going to have the statistics for, and we're going to have a counter, so we can count all the launches that happened for that user for that application ID. So while we're doing that, so every time we see that we had for that application ID and for that user, we just got a counter that was empty, and we after we counted it, we got to 1. That means that we basically had for that period of time, for that month, we got the first user of that with that ID recording the application launch. So knowing that it's the first time, we know that we have to increase the unique users by month, and that's unique user by month is going to be just application ID, date time, again identifier that month, and they're going to be counter. So every time we increase the counter for launches for application and for user, every time we see that for that user there was no information yet available for that period of time, we're going to count this as a unique user. So I'm going to increase the counter on that period, on the same period. So we're going to have similar tables that are going to be by day and by hour and so on. So that's going to be that is how we're going to calculate the number of launches, the number of unique users. So some other things that we're going to do, we're going to also collect information about application crashes. So for the app crashes, so the app crashes collection, we're going to have, I think it's all lowercase, so we're going to have, again, application ID. We're going to, because it's a crash, we're interested in a message for that crash. We're interested in details, so that details with the base60 code and coded stack trace. And we're going to have this what was the date time that a crash happened, and we're going to have count those crashes. So if the same crash happens twice, so basically the crash that has the same message and the same stack trace, we're not going to save it twice, we're just going to increase the count. So to make it quicker for us to count, so actually to identify if we had already the application crash with the same message ID and details, we're going to calculate the hash of the message and details, and we're going to actually compare hashes. So hash is going to be MD5. I think I use the MD5 cryptographic hash for every application. So if I see the application that's with the same, or if I see the crash with the same hash, I'm just going to update the counter. So that's going to be the kind of collections that I'm going to store in MongoDB, and that's going to be used for my API to return the statistics. So a couple of words how it's going to be well implemented. So it was actually already implemented, so I'm going to just give you some details about that. So this whole thing is going to be hosted on AWS, Amazon Web Services. We're going to use load balancer built in that load balancer capability in Amazon Web Services. So we're going to have 3 microservices here. So event service, stat service, and a web service. And those going to be actually Docker containers deployed. So originally I thought of deploying them either in Kubernetes cluster or the AWS container service. I end up doing something else because the overall cost of this first initial design just was too prohibitive for me to run as an experiment. I have it as a Docker container, but I do something else. Stay tuned for, and I'm going to explain it in one of the next videos. This basically event service is going to be Node.js service. It's a lightweight framework. It's easy to use to build the web-facing service. So that's why I used the Node.js and JavaScript to build it. I built this, so the web service is also Node.js and JavaScript service, again for the same reasons. It's easy to write a user-facing application and JavaScript, and also it's easy to connect that application to the MongoDB database. So for the stat service, I decided to use Java and use the Java Spring Boot to write that service. Partially, well, main reason I think is because I just wanted to play with Java and play the different technologies and have a kind of prove that well, I can do that, but also it's because, so another reason was that actually this service is the only service that's not going to have any user-facing endpoints, and it's going to be running completely in the background. And to have kind of more visibility in that service, I wanted to use a mature capacity. So for example, I'm using the Spring Boot activator functionalities to have a health endpoint exposed from that service that I can use to check if it's healthy or not. So kind of all those things Yeah, so the Kafka, again, yeah, original thought was to run it as a hosted kind of, Amazon provided service, and the same for MongoDB. So I ended up doing something else just because of the cost of the overall solution. But yeah, that's kind of, I think that's more or less summarizes the overall architecture of my service. So if you're interested, in the next videos, I'm going to go through every service and every part of this solution in details and show you the code. So thank you for watching this one, and hopefully to see you next videos. Bye.